Hi, everybody. Professor Sackett-Taylor here again with the second part of the video lectures on Chapter 13 from Principles of Macroeconomics. We're discussing the aggregate demand and aggregate supply model. The first video lecture in this series was all about aggregate demand, so we're going to pick up here with aggregate supply. We have to keep in mind what the functions of a firm are. A firm uses inputs such as labor, capital, and raw materials that come from the earth to produce output in the form of final goods and services. The firm's inputs are therefore going to determine the firm's costs of production. And so input prices include things like wages for labor, interest rates for borrowing money to invest in capital, as well as the price point on those raw materials. The output prices are going to be set by the market if the market is competitive. That is the intersection of supply and demand. Or they could be set by the firm if the market isn't exactly competitive. We didn't get too much into this because that's a microeconomic topic. And so when you take principles of microeconomics, you'll learn about different market structures in which a firm may or may not have some power to set prices. So aggregate supply is related to the supply of, or the production of all final goods and services in an economy. So the question we need to answer is, how do changes in the price level affect supply decisions of the firm? When we draw an aggregate supply curve, we're going to hold everything else constant except for the price level and the quantity of aggregate supply. So what happens? Well, it depends. And the it depends here, it depends on time horizon. Are we talking about short run or long run? So we're going to look at two different time horizons to develop two different aggregate supply curves, the long run aggregate supply curve and the short run aggregate supply curve. Let's start with the long run. The long run is a period of time that is sufficient for all prices to adjust. So this is often over a period of decades. The level of output that's produced when an economy has its natural rate of unemployment, we're going to denote by the variable U star. Remember, natural employment does not include structural unemployment. Structural unemployment is the bad unemployment. That comes from economic downturns or recessions. The other forms of unemployment are natural, and so we don't ever expect to get to a 0% unemployment rate. So we're going to make an assumption that we're operating at the natural level of unemployment. This will depend on an economy's resources, technology, and the role that institutions play. What we find is that the long-run aggregate supply curve is actually a vertical line, which means it's not affected at all by changes in price. An economy's ability to produce is the same, regardless of how much paper money is actually present in the economy. So this is one of the reasons why the long-run aggregate supply curve is in fact a straight vertical line. Let's look at our graph. Again, we have the quantity of spending measured as real GDP on the horizontal x-axis. We have price levels relative to a price level of 100 in the defined base year measured on the vertical y-axis. The long-run aggregate supply curve is going to be vertical at what we're calling y star. This is the real GDP level at which unemployment levels are equal to natural unemployment only. As the price level changes, the long-run quantity of goods and services, the aggregate supply, does not change. It's always at the full employment level of output, whatever that be. So the long-run aggregate supply curve, although vertical, can still shift to the right or to the left, because remember, shifts are not tied to changes in price levels. The long-run aggregate supply curve will change with a nation's ability to produce output. So some examples here. The ability to produce output is tied to a change in our access to resources, a change in the development and innovation of technology, and a change in the institutional structure that creates an environment for the economy. So an example of changes in resources. We may have more labor if there's growth in the labor force, or we may have less labor if a lot of people go into early retirement. We actually could have new resources if they're newly discovered. Think about finding a new source of natural gas or oil. We also could have better resources. This is the effect of an investment in human capital, like education and healthcare. Examples of changes in technology might be expansion of internet resources, a growth in telecommunications, or innovation in the robotics market. Examples of institutional changes might be things like changes to the tax rate or the tax policy, or investment that the government puts into researching new technologies. So if we have the long run aggregate supply curve currently at the full employment output level, Y star, an increase in the long run aggregate supply curve means that we can now produce more at the same level of full employment. This would be a shift to the right. A decrease in the long run aggregate supply would mean that we can produce less at full employment. This would be a shift to the left. Remember, right is more, left is less. So why is this curve a vertical line? The answer here is C. Prices have nothing to do with long-term output. In the long run, all prices will have time to fully adjust towards their new equilibrium. So if two economies have identical goods, identical services, identical populations, skills, and resources, they would have the same real output, even if one economy had twice the amount of money, or if price levels were twice as high. That's why it's vertical. It's not impacted by changes in the price level in the long run because prices always adjust. The short run is a different story. In the short run, we're looking specifically at a period of time in which some prices have not been given enough time to fully adjust. So this is often what we call a business cycle or a period of less than 5 years. Each of the three theories that explain why the short run aggregate supply is upward sloping have a common thread. The three reasons are sticky input prices, menu costs, and money illusion. All of them share the same idea behind them that when price level deviates from what a society expects it to be, this will cause real effects in output in the short run. So we're going to break down each of these effects after we look at this in a graph. So aggregate supply in the short run is upward sloping, just like our traditional supply model. The positive slope of the short run aggregate supply curve indicates that as the economy's price level increases, this will lead to an increase in the quantity of aggregate supply, or how much is produced in output in the short run. So for example, if price levels were to rise from 100 to 110, we would see the quantity of aggregate supply measured as spending in real GDP rise from $20 trillion to $21 trillion in the short run. Let's break down those three things that we talked about earlier that are creating this positive slope. The first is sticky input prices. Resource prices tend to be sticky. What that means is that they take a long time to change because often they are written in the form of a contract, right? Output prices can be changed easier. They're more flexible than input prices. And so therefore output prices and input prices might change, but at different rates. So let's suppose that the aggregate price level is increasing, but that input prices tend to be fixed for a short period of time. then higher output prices would increase the profit potential of the firm, but their costs are not changing. So if their costs are not changing, but their profit potential has grown, they're going to respond by the law of supply, which says that they'll produce more output at greater profit potential. The opposite is also true. So suppose the aggregate price level is falling, but input prices are fixed. Lower output prices will reduce profit potential for the firm, and their costs are not changing. So that means that law of supply tells us the firm will respond by producing less output. So output prices are much more flexible since they're generally easy to change by the company themselves. Input prices require other players, right? Prices on a coffee shop can be written on a blackboard and erased and changed the next day. But the cost of coffee beans, the price of actually procuring coffee beans is not as easy to change. And so input prices are sticky, output prices are not. So when price levels increase, companies experience that change as a constant input cost, but a change in their profitability. And if they're more profitable, they're going to increase output. If they're less profitable, they're going to decrease output. Menu costs. This is the costs associated with changing your output prices, right? Like doing that thing that I just said where you erase the blackboard. So because of this expense, firms tend not to adjust their output price immediately when price levels change. So like, let's suppose price levels rise, but the firm doesn't really want to change its output prices quite yet because it's costly to do so. You got to print new menus, you got to change your boards, you got to like print all new stickers, all that. So price levels have risen, but you haven't changed the cost of the price of your output. Then people will view the products that that firm is producing as relatively cheaper, and consumers will want to buy more of it. So the quantity of aggregate supply will rise to satisfy consumer demand. And so in the short run, the quantity of aggregate supply would actually shift to the right. Let's say the opposite happened. Price levels fall, but the firm doesn't actually change their menu. Then buying from that firm now seems relatively more expensive. So consumers want to buy less. So the quantity of aggregate supply will fall to account for the fall in demand. And in the short run, the quantity of aggregate supply would move to the left. The final factor here that we want to talk about is money illusion. Money illusion occurs when people interpret nominal changes, meaning not taking into account changes in price levels, not taking into account inflation. When they see nominal changes and they interpret them or perceive them as real changes. So for example, let's say if price level inflation went up by 10% and your wages only went up by 5%, you might think that you actually have more money, right? Because in nominal terms, you do. There are actually more dollars going into your bank account. But because your wages went up by less than overall price levels, your dollars don't go as far. And in fact, your purchasing power has actually gone down, even though your wages went up. So it's a nominal rise in wages, not a real rise in wages. And a lot of people misperceive this. And so in real terms, your wage has fallen because you won't be able to buy the same quantity of goods, but you might make the mistake of spending as if real wages had gone up. Let's think about the opposite too. Like, let's say price levels fall, but workers tend to not be willing to accept nominal wage cuts. So the firm is going to see, they're still paying their workers the same amount, but price levels have gone down. So they're making less money in terms of revenue with no change in their costs. So they're going to be forced to reduce overall output because profitability has gone down. So this would create a shift to the left of aggregate supply. So what we're going to see is that whenever the long run aggregate supply curve shifts, it's going to take the short run aggregate supply curve with it. The short run aggregate supply curve, in other words, always shifts when there's a long run shift. but the opposite is not true. So let me say that again, right? Whatever happens to the long run shift also happens to the short run shift. But there can be changes in the short run that don't affect the long run, that don't impact the long run. Like the short run aggregate supply curve can shift alone by itself. The things that would shift short run aggregate supply by itself without affecting long run aggregate supply would be things like changes to the price of your inputs, your resources, changes in expectations about future prices, which means that people start behaving differently now, or other forms of supply shocks like weather events or natural disasters, like things that could not be foreseen, surprise events. So we can see that the short run aggregate supply is upward sloping, similar to the traditional supply model, and that increases in short run aggregate supply shift that curve to the right, while decreases in short run aggregate supply shift that curve to the left. To determine how an economy moves from equilibrium to equilibrium in the long run, we have to follow a step-by-step process in order to do it right. So the first step is to begin with a model that's in long run equilibrium. So that means natural employment rates, long run aggregate supply is vertical, short run aggregate demand, downward sloping, short run aggregate supply, upward sloping, quantities equal across all three curves. So they all intersect at one point. Then we have an event. Out in the world, something happens. We determine which of these three curves is the one that's going to be affected by the change and which direction that change is going to shift the curve in. So does it affect long run aggregate supply or short run aggregate supply or aggregate demand? It'll only shift one of those three things. If it shifts it, does it increase that thing or decrease that thing? In other words, does it move the curve to the right or does it move the curve to the left? Then we move the curve, graph the changes, right? Actually shift the curve in the appropriate direction. Then determine your new equilibrium points. Now, be careful. Short run aggregate supply can shift by itself, in which case you may have more than one equilibrium. You'll have a short run equilibrium and a long run equilibrium, which are not the same. However, if you're shifting long run aggregate supply, remember, long run aggregate supply is going to take the short run with it. And so that shift should create just one new equilibrium point. We're going to then compare the equilibriums between the new point after the shift and the old point prior to the shift. We're going to do a lot of this as practice in class together on Thursday. So the long run equilibrium is the quantity of aggregate demand that's equal to both short run and long run aggregate supply. We're going to say this point is A. At this point, there are two things that are true. The economy is at full employment, and the unemployment that exists, remember it's never zero, is equal to the natural rate of unemployment. There's no structural unemployment. This is what the curve looks like when all three of these things are in equilibrium together. There's that point A that exists at the intersection of aggregate demand, short run aggregate supply, and long run aggregate supply. So if we start at equilibrium, we note that there's a single point of equilibrium quantity denoted by Y star. It's a quantity of GDP, real GDP, quantity of spending on consumption, investment, government spending, and net exports that occurs at full employment. Then let's say we're looking at price level changes. Okay, let's look at price level PL, which is a price level below the base year, right? So for below the base year, we're below our P star starting price level. Here, we're at a point where aggregate demand is greater than short run aggregate supply. And so if we have enough time in the long run, what we know will happen is that prices will face an upward pressure towards equilibrium, and that price will adjust towards equilibrium to get rid of this shortage. On the other hand, if prices are high, meaning they're above P star, then we have a short-run aggregate supply that is greater than aggregate demand, or in other words, a surplus. So prices will face a downward pressure towards equilibrium if they're allowed to adjust over time. So in the long run, changes in the price level will not impact the equilibrium because prices will be allowed to adjust back towards equilibrium, either by pressure from the surplus pushing prices down or pressure from the shortage pushing prices up. So with the aggregate demand and aggregate supply graph, which is the thing, which variable are we measuring on that vertical axis? It's price levels measured by the GDP deflator. So, okay, let's do a practice here. Let's suppose there's a technology shock, okay? So we have to begin with our long-run equilibrium model, and then we ask ourselves, which curve is going to shift? Which direction is that curve going to move? And therefore, where is my new equilibrium that will tell me what happens to output, employment, and price levels? So if there's a technology shock, this is going to impact long-run aggregate supply. But remember, long-run aggregate supply takes short-run aggregate supply with it. So they're both going to move. Which direction? Well, usually technology is a positive thing. We don't tend to see negative impact of technology. We're usually innovating and becoming more productively efficient. So we're going to see long-run aggregate supply and short-run aggregate supply increase, which means a shift to the right. When these two curves move to the right, what are we going to see happen in the graph? Well, on the horizontal axis, overall output measured as real GDP will increase, right? We're further to the right. Employment levels will stay the same. We're at full employment because we're still working with the long run aggregate supply curve. And remember, because aggregate demand is downward sloping, when we shift the long run aggregate supply and long run aggregate, short run aggregate supply curves to the right, that new intersection point is going to be lower on the aggregate demand curve, therefore reflecting a lower price level. Prices in the economy overall will go down. Let's look at this in a graph, right? So we start out here, long run equilibrium, all three curves intersecting at point A. We then shift, because we have better technology, we shift long run aggregate supply to the right, which pulls short run aggregate supply to the right with it. So they both move to the right. We now find our new point of intersection. Here it's called point B, where all three curves intersect. We can see that at point B, unemployment rate hasn't changed because we're still operating at full employment. That's an assumption of the model. But we can say that overall output has increased. Y double star is greater than Y star, and price levels have decreased. We're now at a price index of 95, which is a lower overall price level than the base year. This is another example. I'm not going to go through it because I'm going to save some of these examples for class, but I would like to kind of bring this full picture for you. So where is this model helpful? It's helpful in understanding how different exogenous shocks or different exogenous events are going to impact overall economic activity. So in general, recessions tend to be a little bit unpredictable, but we can know when we're in trouble or when we are risking a recession because we have this model and we can use it as a predictive tool for understanding the impact of a variety of factors. This long run and short run aggregate demand, aggregate supply model helps us understand macroeconomic impacts from real world events. And we can use it to evaluate past recessions and understand why things happened the way they did and how things played out, but also to analyze possible policy remedies to these events should they occur again in the future. And that's where we're going next. Fiscal policy and monetary policy. How can the Federal Reserve Bank help us to stabilize an economy when there are real-world events that might be shocking the system and producing outcomes that are unfavorable? Okay, that's chapter 13. There's a lot in here. It brings in everything we've been talking about this semester. So please go back, look at these graphs, because on Thursday, when I see you in class, we're going to be working with this model graphically to make some predictions about what would be the outcome as the result of some real world changes. Okay, I'll see you then.